Hello all. So in unit 2 we have discussed about statistical learning and data pre-processing. In statistical learning we have discussed about central tendency and variability, right? So using these concepts of statistical learning we apply in various areas of machine learning like data pre-processing, which will actually helps us in analyzing the data, which will improve the model's performance. Okay, so today in this session we will go for the practical sessions. So we will apply the concepts of central tendency and variability on a sample data set and see how does that actually help us in machine learning model. Okay, so let's quickly recap what is central tendency. We have seen central tendency is a statistical measure that will actually identify a single score of representation across the entire data that is available. That is, we use central tendency basically to summarize the data with a single value which will actually represent the center point of the data set. So we have also seen three different measures of central tendency: mean, median and mode. Mean is nothing but the average that is obtained by summing all the data points. Median is nothing but the middle value. So the middle value is changed if you have odd number of values and even number of values. If you have odd number of values, median is taken as x into n plus 1 by 2, and if it is even values we take the summation of that. Okay, and we've also seen mode, which is nothing but the most frequently repeated value in the data set. So these three are the three measures of central tendency. And then we have seen variability also. So central tendency will give us one value representing the entire data set, whereas variability will actually gives us the spread of the data, how far the data points are spread in the data. Okay, the dispersion or a statistical measure that will actually explain the data points and how data points differ from each other in central tendency is represented by variability. And we have seen these three important concepts of variability, that is range. Range actually represents the difference between minimum and maximum value in the data set. And then we have seen variance, where variance will actually measure how far each number in the data set is from the mean. How is each data point dispersed from the mean point is represented as variance. And then we've also seen standard deviation, which is nothing but the square root of the variance. Okay, when we look into the variance, variance is different for population, variance is different for sample. Well, let's look into sample, which says summation of all the values from I is equal to 1 to n, each data point, square difference between each data point and the mean by total number of samples minus 1. Okay, so this is how we calculate range, variance and standard deviation, with which we will get the variability. Okay, so understanding central tendency and variability are very crucial when we try to interpret the data and when we try to make conclusions from the statistical analysis. These two actually gives us insights into data distribution along with the characteristics of the data, which will help the machine learning model to make decisions and give accurate predictions. Okay, now let's get back to exercise 2, which is applying central tendency and variability on a given data set. Let's go hands on and check how do we apply. Take a sample data set, take an array of values, apply central tendency and variability and see the result. Okay, so here I'll import NumPy library, and for statistical operation SciPy. Okay, so I'll import NumPy as NP, and from SciPy I import stats, and then I'll create a sample data set. Okay, I will just take an array of values into a data set. I'm not taking row and column. Let me explain you these concepts with respect to a simple array. Okay, now when you talk about, first let's talk about central tendency. So we will have to calculate mean, median and mode. Okay, so in NumPy we directly have the function np.mean. Okay, so directly take np.mean of this particular data, and then for median also we can directly take np.median of data. But when we talk about mode, we also have to observe the statistics of the data, right? So first, for calculating mode, we have to arrange that in the ascending order and then find out the most frequently repeated value. Okay, so for mode result I am using stats. Okay, for handling scalar values basically. Okay, keep dimensions is equal to true is used for keeping all the dimensions true for variable output, and then I say mode is equal to mode underscore result of mode of 0 to extract the mode value. Okay, now I'll print central tendency. I am not using variability here. I'll print central tendency and say print mean, median and mode. Okay, so the mean value here is displayed as 14.8. Let's observe the values here: 12, 15, 13, 16, 14, 15, 17, 14, 16 and 16. Okay, on an average the value here is 14.8 and the median value here is 15. Okay, so it is actually the average of 14 plus 15. Okay, so that is 15 and the mode is 16. Most frequently repeated value is 16. Okay, 14 is repeated twice, 15 is repeated twice, 12 once, 17 once, 16 thrice. Hence mode value is repeated, mode value is given as 16. So this is how we calculate central tendency. Okay, and other concept of statistics that we have seen, statistical learning that we have seen, is variability. Okay, so in variability, let's calculate range, let's calculate variance and let's calculate standard deviation. Okay, if you want to calculate range, just give np dot peak to peak value of the data. When I say peak to peak value, it is nothing but maximum minus minimum value. Okay, so in NumPy we directly have this function np.ptp of data, which is peak to peak value of data, and for variance also we directly have var function. So np.variance with respect to the data. Okay, and then I give standard deviation np.sample standard deviation. Okay, now I am printing range, I am printing variance and I am printing my standard deviation. Okay, so this is how we calculate range, variance and standard deviation. So this is how we calculate range, variance and standard deviation using the existing functions. Okay, now when you talk about DDOF here, it is degrees of freedom. Okay, this is actually used when we calculate standard variance or standard deviation in statistics. So basically default value is 0. This we take it when we go with entire population, but here as I am taking samples, I am putting DDOF is equal to 1. Okay, degrees of freedom, differentiating degrees of freedom. Okay, so this adjustment is important when you have sample rather than the entire population. Okay, now you can also design range, variance, standard deviation, also mean, median, mode with respect to the formulas that we have discussed. Let's also see that. So here in this case, I've imported NumPy as NP and then I've created a data array. Okay, using NumPy np.array, I have created a simple array. And if you want to calculate range, range is nothing but maximum value minus minimum value with respect to the data, right? So np.max of data minus np.minimum of data. You can calculate range this way, or you can also calculate range by using peak to peak function of the data. Okay, so when you calculate variance, you also know the formula for variance, which is summation of xi minus mean whole square by n minus 1 when we are taking entire population. So you can calculate mean first, that is np dot mean of data, and then you can do the squared of deviations, data minus mean into double square, and then you can also use np dot sum squared deviation by length of data minus 1. Okay, so using formula also you can calculate variance. Similarly, standard deviation is nothing but square root of the variance, which is I am using np dot square root. Now display your data, display the range, display the variance and display the standard deviation. Okay, so these are different ways in which we can calculate central tendency and variability on a given data set. Thank you so much.